Welcome students. Let us see one more question. This question says a solid cylinder. First of all, please take care. This is solid cylinder and understand the meaning of solid cylinder. That it's filled with some material from inside, right? So there is a solid cylinder. It's made of transparent glass. So it is made of the transparent glass of refractive index 2 upon root 3. So its refractive index of the glass is 2 upon root under 3. It is surrounded by air. So basically this is the mu g, and this is mu g. This inside material is mu g. Inside this cylinder is glass, and outside that is the air, like this. Outside air, and we know the refractive index of air is basically 1, right? A ray of light traveling in air hits the cylinder at the center of one circular face at a non-zero angle theta to the normal. Please see. So let me draw the cylinder again. So there is a ray of light which is traveling from air or in air, and it is going to strike this cylinder at an angle of theta with normal. So which normal? From what surface? From which surface it is normal? So if you try to visualize like this, so this is the cylinder like this. So it is perpendicular to this circular surface. So its perpendicular is like this. So its perpendicular direction I can draw like this. You can imagine it this cylinder in vertical position. So you will visualize that this yellowish dotted line is normal to this circular surface, right? So a ray of light traveling in air hits the cylinder at the center. That's also important. It is not coming like this, it is not coming like this, it is coming at the center of the one circular face at an angle of theta to the normal. So my ray of light is coming like this. So this is the center and this is the angle theta. I hope you are visualizing the situation, right? And refracts as it enters the cylinder. So when a ray of light encounter a change in medium, it goes in refraction. So outside this cylinder there is air, inside the cylinder that is a glass, and it is going to encounter a change in medium, so it will suffer from refraction, right, as the question says as well. The ray then strikes the curved surface. So the question is saying when this ray propagates inside the glass, it will strike with this curved surface. Where is the curved surface? Please see, this is the curved surface. This is the curved surface in this vertical manner, vertical visualization. This is the curved surface, right? So to explain this statement, we have to apply the law of physics, law of refraction. So let us try to visualize how and what will going to happen with this incident ray that is coming at an angle of theta with the normal, right, as shown in the figure. So first of all, there is change in medium at this surface, at this circular surface. The ray will encounter a change in medium from rarer medium to denser medium, right? Glass is denser with respect to air, so it is going to encounter a change from rare to denser. So what will going to happen? See, if there is no change, if there is no any change in medium, so this ray will propagate like this ray will pass like this. There is no change in any direction, no change anything if there will be no change in medium. But we have a change in medium. What's the change? It is going to enter in a denser medium. So what will happen? If a ray of light goes in a denser medium, it bends towards the normal. Where is the normal? This yellowish part is the normal. So this ray of light bend towards the normal. See, this ray of light has bended towards the normal. This yellowish line is my normal. So this ray of light is bended towards the normal. So it will pass like this. And when it will pass like this, it is going to strike this curved surface. So that's the explanation of the statement. It enters the cylinder, the ray then strikes the curved surface of the cylinder at an angle of incidence equals to the critical angle. So now the ray has traveled till its curved surface, and what is going to happen here? The ray will the ray will in, the ray will the ray will follow the total internal refraction. Why? Because it is saying that it is incidence the incidence angle at this curved surface is equal to its critical angle. What is the critical angle? Critical angle is that angle for which angle of refraction is 90 degree. I hope you understood what is the critical angle. So where is the incidence angle here? Let us suppose this point is B. So I want to know what is the incidence angle at B. What is the incidence angle at B? So to know the incidence angle, first of all, I have to find where is my normal. So the normal to this refracting surface will be like this. So where is the incidence angle? This is going to be incidence angle. I am indicated it by I, and it is this I is as a critical angle. Its value is equals to its critical angle. What is the meaning of this critical angle? It meaning is that, see, when nothing will going to change, so this ray will pass like this, because inside the glass, outside is air. Again there is change in medium, so it should follow the refraction rule, right? But it is coming at an critical angle. So what is the meaning of critical angle? It will pass with a angle of refraction equals to 90 degree. See, when a ray of light passed from glass to air, it means denser to rarer medium, it will move away from the normal. So how much away? So it will bend at the 90 degree. See, 90 of 90 degree is the angle of refraction. So from the normal it will makes 90 degree, and it has bended away from the normal, as you can see. So it will pass like this. This is the angle of refraction. This is the total internal refraction, and this is for this happening, this incidence angle is I. So this is the situation, right? So we have to find the value of theta. So let us try to solve this. Till now I have explained each and every term, each and every concept related to this question, right? So first of all, we should know the Snell's law. That is the law of refraction. That is the Snell's law, right? Let us try to apply Snell's law at point B, right? So at the point of incidence, in the incidence part, mu z, that's the refractive index of glass, into sine of I, that's this incidence angle I, should be equals to mu a, that is the refractive index of air, into sine of 90 degree, that's the angle of refraction for this critical incidence. So mu z, we know the mu z, yes, we have the mu z, that is the 2 upon root 3. So it should be 2 upon root 3 into sine of I is equals to mu a, that's the air, and sine 90, that's the 1. So sine of I is equals to root under 3 by 2. So from here we can get the value of I as well. I is equals to 60 degree, right? So if this is a 60 degree sorry, if this is 60 degree, this angle I is 60 degree, so What is going to happen? See, if this is 60 degree, this is again 90 degree, because this circular surface normal and this curved surface normal both are perpendicular. So this is going to be 30 degree from the angle sum property, right? This is 60, this is 90, so this is going to 30 degree, right? Now again apply the see why I have find it this 30 degree, because this is the angle of refraction for this point of incidence, let us suppose A, right? What is the angle of refraction? Angle between refracted ray and the normal, and yellowish dotted part is my normal, so I need this angle, so this is the 30 degree. Again apply the Snell's law, so that is the mu A outside air into sine of theta, this incidence angle theta should be equals to mu z, that's the refractive index of glass, into sine of 30, that's the angle of refraction here, as you can see this 30 degree. So mu a is 1, sine theta should be kept as sine theta, mu z is 2 upon root under 3, and sine theta is 1 by 2, that's the half. So from here we can solve this. So sine theta is equals to 1 upon root 3. So from here we can get the value of theta as sine inverse 1 over root under 3. Let us check my option. Yes, that's the answer to option number B. So students, I hope you have understood this question in a proper manner. If there is any doubt, you can tell me in comment section. Thank you. Thanks for watching.